Matrix multiplication. Suppose I have a matrix A of order 2 by 3, B is a matrix of order 3 by 2, and C is a matrix of order 2 by 2. Now I want to see if it is possible to find AB. The order of A we have 2 by 3 and order of B is 3 by 2. So you can see that this one has a matching here. So then it's a AB possible, and order of AB will be 2 by 2. Now we see BA. The order of B is 3 by 2 and order of A is 2 by 3. Still we see matching here. So that one is also possible, and the order of BA will be 3 by 3. So now we can see that AB not equals BA because they are of different orders. Sometimes they will be equal. Then we call them commutative matrices. Now let me see what happens to AC. The order of A is 2 by 3 and the order of C is 2 by 2. We don't see matching, so it's not possible. Same way, if you see BC, so order of B we have 3 by 2 and C is 2 by 2. We have a matching in here, so that one is possible, and the order of BC will be 3 by 2. Now let us see if CA is possible. The order of C is 2 by 2 and order of A is 2 by 3. Yes. So CA is possible and order of CA will be 2 by 3. Now we want to multiply A with B. A in the left side, B on the right side. To do that one, first I need to mark my rows in the left matrix and column on the right hand matrix. So you have 3 times 1 is 3. Plus 2 times 3 is 6, plus 1 times 1 is 1. Same way we do all of this. So you can see this row goes in the second column, 3 times 0, 2 times 1 and 1 times 2, like this. Now we are done with the first row, go to the second row. Second row will go with the first column, 1 times 1 plus 0 times 3 plus 2 times 1. Same way, 1 times 0, 0 times 1, 2 times 2. So then you can further simplify and write your final form of the matrix. So if you see, the order of A is 2 by 3, order of B is 3 by 2, so 3, 3 matches. So remaining is 2 and 2. So the order of AB will be 2 by 2, and then you can see exactly here, 2 rows, 2 columns. I'm taking another matrix just for simplicity. You can see the matrix on the left side, I have order 1 by 3 because you have 1 row, 3 columns. And the second matrix on the right side, we have 3 rows, 1 column. So then they match here. Now we can multiply. And when you multiply, the order of this matrix will be 1 by 1. That means it should have just 1 entry in here. So let's see how it is. We have only 1 row, 1 column here. So multiply this row with the column. So what do? You multiply 1 times 0 plus 2 times 1 plus 3 times 1 and done. So then you get only 1 entry, 5. So this is the matrix of order 1 by 1. 1 row, 1 column. We have given 3 matrices. A is a matrix of order 2 by 4, B is a matrix of order 4 by 2, and C is a matrix of order 4 by 2. Now we want to find A, B minus C if possible. So first you can see the order of A is 2 by 4. And BC will have same order. B has order 4 by 2, C is 4 by 2, so B minus C also will be 4 by 2. Now it's possible. And the resultant matrix should be of order 2 by 2. So we'll do it now. So first you see, you can do order of operation, do the parentheses first, b minus c. So b minus c, subtract c from b, so you get negative 1, then you get a 0 here, then you get 2 minus 1, 2 minus 1 will give you 1, and then negative 1 will give you negative 2, 5 minus 1 will give you 4. Same way we did already, negative 1 will subtract, you get a 0, so 1 minus 1 is 0, 4 minus 1 is 3, and 0 minus 1 is negative 1. So you got b minus c. Now you need to multiply with a, so our a matrix is, and we got our b minus c is like negative 1 0, 1 0, negative 2 3, 4 negative 1. So now if you continue multiplying, you will see that 0 times negative 1, negative 2 times 1 is negative 2, and then 0 times gone, so 2 times 4 is 8, so you got this one here. Same way if you continue, you'll see at the end your answer will come out like this. You get a negative 16 in here, and you will get 6 in here. I'll show you this one in the calculator. So this element actually is 6. You can rewrite this one, you have a 6 in here. So the final version of this is 6, negative 2, negative 16, 6. Let us see this in the calculator. So to continue in calculator, you have option here is a matrix. Go to second, matrix, then go to edit, and first I'm taking matrix A, so we have 2 rows and 4 columns, so this 2 I'll change to 4, and then give the entries. First I have a 0, then I have negative 2, then I have a 0, and then I have a 2. So I'm done with the first row. Second row will be 12, then I have 0, then I have a 2, and then I have a 0. So I'm done with this matrix. Now you need to go to second, mode. Again you go to second, matrix. Now we'll be editing the second one, number 2, B matrix. So go to 2, so B matrix is coming. Now this one has 4 rows now, 4 rows and 2 columns. So same way you give the entries. So you can see I have all the entries here for B. Now I'll be doing for C. Go to second, mode, go to second, matrix, go to edit. Now hit 3 for the third one. And same way you have 4 by 2, and give the entries for this matrix. So you can see I have given all the entries for C, and we are done. Go to second, mode. Now see what we do. We go to second, matrix. Now to call the matrix, first we bring 1, so A is here. I need to multiply here, and then call your B matrix, second matrix. I'm going to the second one is my B, minus C. Second matrix, C is in 3, and then enter here. So you can see 6, negative 2, negative 16, 6. That exactly the entries we have here. 6, negative 2, negative 16, 6. We are done. Now we want to see how we can write a system of equation in matrix form. So this one is very simple. You first write 2, 3, 1, negative 1. This is a matrix of order 2 by 2, and then put a column matrix in here, x, y, and then you write on the right hand side 13, negative 1. So that is the representation of matrix form from the system of equations. So what you do, you write the coefficients 2, 3 separated like that. First row will be constituted by 2, 3. Second row will be 1, negative 1. Or you can say first column is 2, 1 here, 3, negative 1 here. And then you have 2 variables x, y, keep the order. First x, then y. And then this is the form. We are done.